Hello class. This video is going to focus on 2.1, which is angles and congruence. We have three different goals for this video. The first is I can analyze figures using the definitions of angles and parts of angles. Next, I can calculate angle measures using the definitions of congruent angles and angle bisectors. And then I can analyze figures using the characteristics of adjacent angles, linear pairs of angles, and vertical angles. Open your textbook to page 65, where you will begin to take notes. So we're going to have lots of definitions in this video. So lines and portions of lines intersect to form angles. A ray is a part of a line consisting of a point on the line called the endpoint of the ray, together with all the collinear points on one side of the endpoint. So the important thing when you are naming a ray is that the endpoint has to be named first. So in this ray, point A is the endpoint, so we name it either ray AB or ray AC. And you name it with two points on the ray. Two collinear rays with a common endpoint are opposite rays. Opposite rays form a straight angle, which has a measure of 180 degrees. So opposite rays form a straight line or a straight angle. And again, that measure is 180 degrees. And then an angle is a pair of rays that have a common endpoint. So two rays make an angle, and then the common endpoint is your vertex. So where that common endpoint is, that point, when you name it, always needs to be in the middle. So you can name it either with that vertex, so you can name it with A, so angle A, or you can name it with three letters. So you need 1 point from each of the rays, and then the vertex should always be the middle point. So this could also be called angle DAB, angle DAC, angle CAD, or angle BAD. Okay, the rays are called sides of the angle. The common endpoint is the vertex. So an angle has a vertex and then two rays that make up that angle. So in this angle, the vertex is A, point A, and then the sides are ray AD and ray AB. You could also call that AC. And then points D, A, B, and C lie on the angle. So those points are on the angle. Okay, this is on page 66. An angle divides a plane into three distinct parts. So points D, A, B, and C lie on the angle, so that is the first part. Points G, F, and H lie in the interior of the angle, so inside of the angle, the blue part. And then points I, J, and K lie in the exterior of the angle or outside of the angle. Again, that's the blue part. Okay, example 1, identify angles. This is on page 66. So name all the angles that have D as a vertex. So D. So the point in red, that is where D is, and then you want to name all the angles that have D as a vertex. So there are 10 of them. So they are angle EDF, angle EDG, angle FDC, angle GDC, angle GDH, angle CDH, angle FDH, angle EDH, angle EDC, and angle GDF. Okay, name the sides of angle 2. So angle 2, I'm going to draw a little vertex there. So angle 2 is where I have that red arc. And the sides of angle 2 are going to be ray BA. And then ray BD. Now I could have also called it ray BG instead of BD because G is also on that ray. Name a point in the interior of angle FDE. So angle FDE. So I'm going to draw a little arc from one ray to the other A. So any point that's inside of that arc would be an interior point. So the only point that's inside and not on the angle is point A. And then name all of the points in the exterior. So outside of angle FDE, let me change colors. So outside of FDE, I'm going to do in blue. So any points out there that are not on the angle and not inside the angle. So we've got 3 points. We've got point C, point H, and point G. So C, H, and G. Okay, we've got some more definitions on page 67. The measure of an angle is the measure in degrees of the space between the sides of the angle. Angles that have the same measure are congruent angles. Congruent angles are indicated on the figure by a matching number of arcs. So these red arcs inside of the angles, that means that they are congruent because they have the same number of arcs. And we can say that angle QTR is congruent to angle STR. A ray or segment that divides an angle into two congruent parts is an angle bisector. In the figure, ray TR bisects angle QTS. So we have heard bisector before with segment bisector. So now we've got a ray acting as a angle bisector. So the measure of angle QTR is equal to the measure of angle STR, and they are both 60 degrees. So ray TR is an angle bisector. It cuts it in half. Okay, example 2, congruent angles and angle bisectors. This is on page 68. So in the figure, ray BA and ray BC are opposite rays, and ray BD bisects. So if they're opposite rays, that means that if we add up all the angles on this line, it's going to equal 180 degrees. And then it also tells us that ray BD, so this ray right here, bisects angle ABE. So that means that angle ABD and angle EBD are congruent. Okay, so those two angles are congruent, so I drew an arc to show they're congruent. Okay, we can solve for this in 2 steps. First, solve for x, then find the measure of angle DBE. So we already said that those two angles are congruent, and by the definitions of congruence, these angles have the same measure. Okay, so I can start off by saying, here, let me just draw the arcs again. So I'm going to say that the measure of angle ABD is equal to the measure of angle DBE. Okay, so that means I can take what they are equal and set them equal to each other. So measure of angle ABD equals 4x plus 14. And the measure of angle DBE equals 8x minus 32. Okay, so then we're going to solve that equation. So I'm going to start by subtracting 8x on both sides. Now I know in your book it starts by subtracting 4x, so you can do that too. It's going to give you the same answer. So 4x minus 8x is negative 4x, plus 14 comes down, equals, and then negative 32 comes down. Okay, so now we're going to subtract 14 on both sides. And then we have negative 4x equals negative 32 minus 14 is negative 46. And then I'm going to divide by negative 4. And then once you divide by negative 4, you're going to get x equals 11.5. Okay, so that's step 1. Now in step 2, because we are asked to find the measure of angle DBE, we substitute 11.5 for x in the expression. So we're going to take the measure of angle DBE equals 8. Instead of x, we're going to put 11.5 minus 32 Okay, and then you can calculate 8 times 11.5. That's going to give you 92. And then 92 minus 32 is going to be 60 degrees. So the measure of angle DBE is 60 degrees. We could also say the measure of angle ABD is also 60 degrees since they're congruent. Okay, we are on page 69, special angle pairs. So there are 3 special angle pairs. The first, adjacent angles, are 2 angles that lie in the same plane, have a common vertex and a common side, but have no common interior points. So adjacent angles share a common ray. So in this example, both angle 1 and angle 2 have the ray that I just drew in red. So they have to have one of their rays have to be touching, and then they're adjacent. Now in the non-examples, angle 1 and angle 2 are not touching, so they are not adjacent. Next, we have a linear pair is a pair of adjacent angles with non-common sides that are opposite rays. The sum of the angle measures is 180 degrees. So a linear pair is 2 angles on a straight line. So angle 1 and angle 2 are on a straight line, and if you add their angle measures together, it's going to be 180 degrees. In the non-example, we do not have a straight line, so those are not a linear pair. However, they are adjacent. And then vertical angles are 2 non-adjacent angles formed by 2 intersecting lines. Vertical angles are always congruent. So in order for it to be vertical, I always say if you draw a bow tie, those are your vertical angles. So angle 4 and angle 2 are vertical angles. Same with angle 1 and angle 3, they are vertical. They cannot be adjacent. That is the main thing, and they have to be formed by 2 intersecting lines. In the non-examples, we do not have 2 intersecting lines. We've got 2 rays and a line, or 4 rays if you want to say. Okay, example 3, vertical angles and angle pairs. This is on page 70. So how many pairs of adjacent angles do you see in the figure? And then list 2 pairs. Okay, so I'm going to verbally say all the pairs, and this is also going to be the same answer for C. However, when we get to C, I am not going to write them down. So if you want to write them down when I say them, that is fine. Okay, so our pairs of adjacent angles that are also linear pairs, we've got angle ABE and angle EBC. We've got angle EBC and angle CBD. We've got angle CBD and angle DBA. And then we've got angle DBA and angle ABE. So there are 4. And again, I'm not going to list them. I just said them. So you can write down 2 pairs that I just said. Okay, identify 2 pairs of vertical angles in the figure. So remember, vertical angles make that bow tie, so we should have 2 pairs. So the first pair is angle ABE, and angle CBD. Okay, and the second pair I'm going to do in blue. Okay, so that is angle ABD and angle EBC. Okay, so there are 2 pairs of vertical angles. Okay, how many linear pairs do you see in the figure? List each pair. I already listed the pairs when we did A, and there are 4 pairs, 4 linear pairs. And again, you can go back to part A, and if you want to list them out yourself, just listen to what I'm saying. Okay, in D, we want to find the measure of angle EBC. So the measure of that angle. Well, we know that angle EBC and angle ABD, those are vertical angles, and vertical angles are congruent. So let me write this. The measure of angle EBC is equal to the measure of angle ABD because they're vertical angles. And so I can say that the measure of angle EBC is 138 degrees. Okay, and then we want to find the measure of angle ABE. So let me switch colors. Measure of ABE. So this angle in green. Well, we have a linear pair here. So let's call this angle X. And then we have this angle. So if you add those together, it's going to be 180 degrees since it's a linear pair. So I have X plus 138 equals 180. And then we just need to solve for X. So minus 138 on both sides. And we get X equals 42. So that means the measure of angle ABE equals 42 degrees. Okay, this is the think about it on page 70. Can vertical angles also be adjacent angles? Explain. So pause the video for a minute, think about it, and then come back for the answer. So the answer is no. Vertical angles cannot also be adjacent angles because by the definition of vertical angles, they are non-adjacent angles. So they cannot be adjacent angles. They can't touch each other or they can't share a common ray. Okay, that is the end of 2.1a. Remember, in order to move on, you need to get at least a 75% on the quiz.